so this is chapter P, section P.7, which is solving inequalities algebraically and graphing. So we're going to look at absolute value inequalities, quadratic inequalities, and then some application problems. Okay, so solving absolute value inequalities, the thing you need to focus on is the direction of the inequality symbol. So if we look at this one to start with, the absolute value is less than something. So if it's less than, it means it's going to be an and inequality, which means it's going to be one single compound inequality. If the inequality symbol is greater than, then it means it's going to be an or inequality, and we're going to have less than something or greater than something else. And this can be replaced with the greater than or equal to or less than or equal to as well. Okay? So now we're going to look at some examples with those. So the first example we have is absolute value of x plus 3 is less than 5. So that less than means it's going to be and. So that means that I take the x plus 3 is less than 5 and I make it an and inequality. So I compound inequality and I put negative 5 over here. Then we solve that. So we subtract 3 from all parts and we get negative 8 is less than x is less than 2. So then if I were to graph this, we have negative 8, we have 2. These are going to be curved brackets because it's not or equal to, and it's shaded in between. Okay, so that's an and. Now if we take the same inequality, so let's take x plus 3, but let's make it greater than or equal to 5. So I added the or equal to, just to give a different example, but I also changed it to greater than. So that tells me it's going to be an or, which means I'm going to say x plus 3 is greater than or equal to 5. So that's the original, just minus the absolute value signs. Or x plus 3, x plus 3 is going to be, I'm going to flip the sign and flip the symbol, the sign, with the 5. So, or it's less than or equal to negative 5. So over here I get x is greater than or equal to 2, or x is less than or equal to negative 8. So what that means is we have negative 8, we have 2. These are going to be brackets because they're or equal to, so it's going to be greater than 2 or less than negative 8. Okay? So that's absolute value inequality. Okay, so now quadratic inequalities, the first step I need to do is make sure they're equal to 0 or set with 0 on a side. So I have 5x squared minus 11x minus 12 is greater than or equal to 0. So we can graph this. So you could type this into Desmos or your graphing calculator, or we can solve it algebraically. So I'm going to look for two numbers that multiply to negative 60 and add to negative 11. So you can try a couple different numbers, but that ends up being, we know negative 15 and 4 are going to add to negative 11 and multiply to negative 60. So I'm going to put 5x squared minus 15x plus 4x minus 12. Then we're going to group. So this, I can take out a 5 and an x, which leaves me with x minus 3. And here I can take out a 4, which leaves me with x minus 3. So then I group and I get 5x plus 4 and x minus 3. So from this I can tell that my two zeros are going to be negative 4/5 and 3. And you can see on our graph over here, there's 3, there's negative 4/5. So this is asking us, where is this going to be greater than or equal to 0? So we want to write this as intervals. Where is my graph going to be above that x-axis? So if I let's take my highlighter here. So this area here and this area here are both above the x-axis. So how I write that is I would say negative infinity to my first 0 point, which is negative 4/5. And I'm going to use curved brackets because, nope, I'm not going to use curved brackets. Just joking. I am going to use square brackets because, oops, of that or equal to. So it depends on my symbol right here. If it was just greater than, I would have to use curved brackets because it can't be equal to 0, but this one it can. So that's why I'm using square brackets. And then we know it starts again at 3 to infinity. Okay, so that is how we do quadratic inequalities. The other thing that you might see as you're doing examples is you can write this as the same way we just did, with the union symbol in between them. So these mean the same thing. Sometimes it's acceptable to leave it out and just write it one next to another, but this symbol right here means or. So being able to use that union symbol means it's either this area of the graph or that area of the graph. Okay? So that's quadratic inequalities. And then the last thing that we were going to talk about is solving a cubic equation graphically. So let's say we have x cubed plus 2x squared minus 1 is greater than or equal to 0. Okay, so you can graph this on your graphing calculator or on Desmos, and if you graph it, you're going to get something that looks like this. And so this right here is telling us that we're looking for something that's above 0. So again, if I use my highlighter, so this little piece right here and this little piece right here. So how we would represent that. So if you use your graphing calculator, you find those approximate values. You can say this is going to be negative 1.62 to negative 1. Notice I'm using square brackets because that's or equal to. And then you can say union 0.62 to infinity. So when you're giving these, again, you're just giving those x values, remember? So here, here, and here, those are the x values you care about. And if we were asked for if this was the opposite symbol right here, if this was less than or equal to, then you'd be describing these two pieces. Okay? So you're looking for the different areas of the graph depending on the inequality symbol. So as you're working through those examples, let me know if you have any questions.